Here we see how the large and small boles interact with each other magnetically. Notice how the small blue bowl is forced to flip over and then floats within the large red bowl. The small red bowl responds quite differently, as you can clearly see. Then we find the same rules in effect within the large blue bowl. Now you see how the orbital distance of the small bowl set is determined by the spacing between the large red and blue bowls. This same principle applies to magnetic balls placed within the orbital equator area perpendicular to the large bowls. In this demonstration, a singular magnetic ball is held in place by the magnetic bowls, and then a second magnetic ball is added. Then it was discovered that this orbital effect is there even when the polarity of the magnetic field emitters is reversed. Pouring 2 mm steel balls into the large bowls reveal the true forces at work in the Southern Crab Nebula. A wide variety of methods were used to study the magnetic fields emanating from these bowls. Here we see ferrofluid at work, showing the magnetic patterns formed within these bowl-shaped magnetic field emitters. Then, for the very first time, it's now possible to actually repel non-magnetized steel balls with a static magnetic field. The magnetic field emitted from these bowls induces a magnetic field into the steel ball and then repels it along the axis of these magnetic field emitters. This knowledge is the key to understanding how these magnetic fields confine the nucleus of all matter, from electrons to galaxies. In this experiment, the anode, or the positive side of the high voltage electrical supply, has been disconnected from the lower part of the vacuum chamber. As you can see here, the ejection jets are formed by the magnetic field emitters, even if one of the positively charged anodes is removed from within the vacuum chamber. So you should be starting to understand that a critical mistake was made by scientists when it was assumed that the magnetic fields emanating from matter such as atoms was due to a simple bar-shaped magnetic field within the atom. This assumption led to many ill-formed ideas as to the true forces at work, from the subatomic level to the galactic level. Correct this one basic misunderstanding, and then many difficult problems in science become very clear and easy to understand. Here we see iron filings revealing the magnetic field lines around a bar magnet. Now we see a compass being used to reveal the magnetic field around the bowl-shaped emitter set. Notice that the field emitted from both the bowls and the bar magnet are the same. No wonder mankind was unaware of these bowl-shaped magnetic fields. They were hiding right in front of us the whole time. In this image, the magnetic field lines around the typical structure of an atom, a star, or even a galaxy are shown in magenta. But we need to remember that even though the magnetic field lines measured around matter are of this shape, it is not due to a bar-shaped magnet along the axis of the matter being measured. There are in reality dual bowl-shaped magnetic fields around the nucleus that cause this measured shape of magnetic field lines. So here is the basic shape of the magnetic fields that emanate from a typical structure in space. Now let's examine some structures in space and see if we can't find evidence for this shape at work in galactic formations. Here is how we were mistaken in our understanding of the true forces at work in galactic structures. These large structures in space could not be explained by the currently accepted theory of gravity alone. So as we studied these structures, it was assumed that some extra source of gravity was required to explain how all this matter could be held in orbit around the central star in these galaxies. This is how the theory of black holes became accepted when trying to explain these structures. It was a totally reasonable line of thinking. But it was found that even using black holes with incredible gravity, we could still not explain how these large structures in space are held together and function. So the next mistake that we made was to assume that some other extra matter was there to explain these large structures in space. Along came our theory of dark matter. But even when we applied both the theory of black holes and dark matter to our puzzle, there still were some problems. It seems the universe itself was not only expanding, but that rate of expansion was increasing. To explain this, we came up with the theory of dark energy. So now we have invented three totally unproven theories to explain what we find in the visible and known matter in space: black holes, dark matter, and dark energy. Although I totally believe in plasma formations, there are clearly times where there is much more than just electricity and plasma required to explain what we see in space. This is the case in radio galaxy Hercules A. There is clearly actual matter being ejected along the axis of this galaxy from the evidence we see here. I have undertaken hundreds of plasma experiments, and I am convinced that external electricity alone cannot explain the formation we find in Hercules A. So let's take a look at how matter can be ejected by these bowl-shaped magnetic fields. So now I'm going to show you magnetic ejection utilizing the CERN ball. So this one will shoot these magnets, ordinary magnets, about 25 to 30 feet across the room if I have a large room. I don't have that big a room we're working in right now, so I'm just going to show you what I'll do. So pulls it down here, and I'll just put it in through the bottom, through the hole in the bottom. A little tricky, it doesn't really want to go in there. It's kind of against it. But then you get it to where it's a balance point, where it doesn't take any energy. But once you push it past that balance point, knowing that all matter has a magnetic component to it, you can now see how these incredibly strong bowl-shaped magnetic fields in space could accelerate matter to nearly the speed of light without requiring external electricity, black holes, dark matter, or even dark energy. It is important to note that these bowl-shaped magnetic fields will not always be nice, simple, symmetrical structures. They can be warped, twisted, offset, or one field might even be larger than the other as shown here. But once you understand the basics of this new theory of matter formation due to bowl-shaped magnetic fields, you will be able to easily explain most all of the structures we find in space.